Hi everyone. In this video, we're going to look at how we can go about solving radical equations. So quick reminder, radical equations are any equations where our variable, in this case x, is found under a radical or a root. Remember, those two words are interchangeable. One thing that we're going to want to do is it's important that we're going to isolate the term with the radical. So in this case, we have the equation square root of 2x plus 15, all under the root, minus 6 equals x. We have our variable in our term 2x under the square root. And so we're going to try and get this square root all by itself on one side of our equal sign. And then we can go about undoing that root and solving for our variable x. One thing to note is that it's very important to check your solutions when you're solving radical equations because we can get something called extraneous solutions. And these are solutions that don't make the original equation true. And so we may see an example of that when we're going about solving this equation. So let's first review the steps and then we'll apply them to that equation at the top of the page. So first thing we're going to do is, like I said, isolate the radical on one side of the equation. So anything that is not underneath that radical or root, make it be on the other side. Second thing you're going to do, step 2, you're going to raise both sides to the power that undoes the root. So when I say that, a square root can be undone by a square. A cubed root can be undone by cubing it, and so on and so forth. Step 3, you're going to solve the equation that comes from undoing that root. And then step 4, you're going to check all your solutions. Again, super important here that you check your solutions because like I said at the beginning, you could get solutions that are extraneous or don't make the original equation true. So let's go ahead and apply these 4 steps to our equation. So let me write that here. So the square root of 2x plus 15 minus 6 equals x. So very first thing, I want to get this square root of 2x plus 15 all by itself. So I need to move this negative 6 to the other side. To do so, I need to add 6 to both sides. So I then get the square root of 2x plus 15 equals x plus 6. All right, so we have already done step 1. Now we move on to step 2. And let me rewrite my equation here. We are going to get rid of this square root by raising it to a power. So to undo a square root, we are going to raise it to the second power. We're going to square both sides. So now we just get what's under our root, which is 2x plus 15. But on the right-hand side, it's a little more complicated. Remember, this is a common algebra mistake. You can't just say, oh yes, this is going to be x squared plus 6 squared. No, we have to rewrite this. Remember, just like if we have 3 squared, we say that's 3 times 3. Well, same thing here. This is going to be x plus 6 times x plus 6. So we're going to have to apply the distribution property here. So we're going to do that to the right-hand side. So this is also equal to, remember when you distribute, you make sure you multiply each term in one set of parentheses times those terms in the other. So we're going to do x times x times 6, and then distribute the 6 also. So 6 times x and 6 times 6. So we end up getting x times x, which is x squared, x times 6, which is a positive 6x, 6 times x, which is a positive 6x, and 6 times 6, which is 36. I can combine like terms here. I have a 6x and a 6x. So if I add those, we end up getting a positive 12x plus 36. And then I'll rewrite what was on my left-hand side. So this is going to go all the way. down here. So 2x plus 15. All right, so now we have raised both sides of our equation to the second power to get rid of the square. And so now we have a polynomial equation. So we're going to follow those rules of how we solve a polynomial equation. So our polynomial equation here is 2x plus 15 equals x squared plus 12x plus 36. So remember, when we solve a polynomial equation, the very first thing we're going to want to do is move all terms on one side of our equal sign to get 0 on the other. I don't want a negative in front of my leading term, so I'm going to move my 2x and my 15 to the right-hand side. So subtract 2x, and I am going to also just in the same step subtract my 15. So again, what we do to one side, we do to the other. So I'm going to get 0 on the left-hand side. And then I'll have x squared. I have a positive 12x minus 2x. So we can combine those to get a positive 10x. And then I have a positive 36 minus 15. I can combine those to get a positive 21. All right, so now the second step when we were using solving our polynomial equations is we get to factor this. I am going to use trial and error method. This is a second degree polynomial, so it's going to have at most, 2 prime factors. I know that to get the product of x squared, I need to multiply an x times an x. These numbers here, they have to multiply to be 21, and they have to add together to be positive 10. So thinking of the factors of 21, we know we can do 1 times 21. We can do 3 times 7, and then that's it. Well, I have a 3 and a 7. Those add to be 10, so those are going to be my blanks here. And then so that all of these are positive 10, and a positive 21, we need these to be added. So factoring my polynomial, I get x plus 3 times x plus 7. Then our third step when we were solving polynomial equations is we need to set each of these factors equal to 0 and solve for a variable x. So we have x plus 3 equals 0 and x plus 7 equals 0. To get x by itself, I need to get rid of this plus 3, so I minus 3 on both sides of this equation to get x equals negative 3. To get x by itself in this equation, I need to undo that plus 7, so I minus 7 on both sides, and we get x equals negative 7. Our very last step is we have 2 proposed solutions here, x equals negative 3 and x equals negative 7, but we need to check our solutions in our original equation and see, does it make it true? So let's first plug in negative 3 for our x's. So let me rewrite our very first form of the equation, which was the square root of 2x plus 15 minus 6 equals x. All right. Everywhere I see an x, I'm going to replace it with negative 3. So I get 2 times negative 3 plus 15 under my square root minus 6 equals negative 3. Now we hope it equals. I don't know for sure. That's what we are going to check. So when we're checking, we have to work with one side at a time and then compare our answers. Remember, we're going to need to use our order of operations. I'm going to treat the square root as if it were parentheses. So I need to do everything under the parentheses or under the square root first. So we're going to multiply. So 2 times negative 3, that's going to be a negative 6 plus 15 minus 6. And then I still have addition under my square root, so we'll perform that. So negative 6 plus 15, we're going to get a positive 9. The square root of 9 is 3. 3 minus 6, we get negative 3, which is what we have on the right-hand side. So we get a true statement here. So that means that x minus 3 or x equals minus 3 is in fact a solution. Well, what about for x equals negative 7? So let's check. Same way, we're going to do our original equation. Everywhere I see an x, I am now going to replace with a negative 7. Again, I don't know if this is true. I need to solve one side at a time and then compare. So on the left-hand side, same thing. I'm going to treat this radical as if it was parentheses. So I'm going to perform those operations under there first. So multiply 2 times negative 7, and we get a negative 14 plus 15 under our square root, and then minus 6. The addition, negative 14 plus 15, we get 1. The square root of 1 is 1. So 1 minus 6, we get, I don't have room here, but 1 minus 6 is negative 5. But on the right-hand side, we have negative 7. Are these equal? No. So in that case, we get a false statement here. So that means that x equals negative 7 is not a solution. So we end up with our solutions being x equals negative 3. So x equals negative 7 was an extraneous solution. So again, be very careful. Make sure that you do check all your solutions in your original equation when you're solving radical equations. I hope you find this video helpful and wish you luck as you are solving your radical equations.